Welcome to BVS Pragathi channel. In this session, let's have a look at some more design considerations of broadband SPST switch using gallium arsenide MESFET. So before we delve into the topic, I request you to subscribe to the channel and share it among your friends and family. Now let's go ahead with the topic. So in a SPST switch, we are considering MESFET as a passive two-terminal device with the gate terminal acting as a port for control signal only. And the RF connections are made between drain and source, and the gate appears like an open for the RF signal. The RF impedance between drain and source depends upon the DC voltage applied over here. So for switching applications, low impedance and high impedance. Low impedance state is when the FET is turned on, and high impedance state is when the FET is turned off. So when is the FET is turned on? When Vg is 0. And when Vg is minus Vp, then it is turned off. So this is the equivalent circuit that we are discussing. So RDS is in parallel with CDS. And CG is gate parasitic capacitances, RG is the bias resistor, CP is the parasitic capacitances from the drain and source to the substrate, and LS is a parasitic inductance. Okay, so that is what we are looking at. Now, here is a series switching MESFET. So in a series mode, what we do, the drain and source terminals are the points where the RF signal transverses, and the impedance between these two is controlled by gate control voltage. Okay. Now, to calculate insertion loss or isolation, we draw the equivalent circuit and we apply the voltage twice VL to the characteristic impedance Z0, and the output is terminated with Z0. So the voltage across output is considered as VLD. This is the series configuration. Now let's have a look at the equivalent circuit in the shunt mode. In the shunt mode, the RF signal is between only one terminal, that is source or drain, while the other terminal is grounded. And the control voltage is applied to the gate. Okay. So when it is turned off, the signal transverses between drain and source, and when this is turned on, the RF signal is bypassed to the ground. So the equivalent circuit is, you apply twice VL through an input admittance Y0, and the output admittance, so output is terminated with the admittance Y0, and the voltage across it is VLD. And this is twice VL. Okay. Now, let's understand about some more concepts. So while analyzing a switch, there are two important parameters, that is insertion loss and isolation. So what is insertion loss? Measure of performance in on state. And what is isolation? Measure of performance in off state. So for a series FET, when do you calculate insertion loss? That is when the MESFET is turned on. And for shunt FET, you calculate insertion loss when it is turned off. And what is isolation? Measure of performance of the SPST switch in off state. So when is the switch off in the series mode? When the MESFET is turned off. And when is the switch off in the shunt mode? When the MESFET is turned on. So we have discussed about the salient features just now. Okay. So RF impedance is between drain and source terminals, and it depends upon DC control voltage at the gate terminals. For switching applications, low impedance and high impedance states are obtained by making gate voltage equal to 0 and by using a gate voltage Vg greater than Vp. So here is the insertion loss calculations for series MESFET. So insertion loss is VL square by VLD square. Okay, where is this? Let's have a look at the series FET, where the input impedance is characteristic impedance and output is terminated by characteristic impedance. Okay, so for this it is equal to ZC Z2 by Z0 into Z1 plus Z2 plus ZC into Z1 plus Z2 whole square. And what is ZC? It is ZC is J omega Cp. Okay. And Z1 is J omega Ls. So all these things, the RDS in parallel with CDS and LS. So J omega Ls plus RDS by RDS plus J omega C effective plus 1. And what is C effective? CDS plus CG by 2. Okay. And what is Z0? What is Z2? Z2 is Z0 J omega Cp by Z0 plus J omega Cp. This part. The output Cp in parallel with Z0 is represented by, the impedance is calculated as Z2. That is Z2. Okay. So the same thing can be used for insertion loss calculation and isolation. Only the values change for the on state and the off state. This is for the series MESFET. Okay. Now for a shunt FET, we are considering our gate bias to be 5 kilo ohms. And what is insertion loss? Twice Y0 plus Y1 plus Y2 by twice Y0 whole square, where Y1 is equal to J omega Cp. Okay. Now let's have a look at the shunt switch. Y1 is J omega Cp. That is what we are seeing at the input. Okay. Now RDS in parallel with CDS and CG, all that forms Y2. RDS plus J omega C effective by J omega Ls into RDS plus J omega C effective plus RDS into J omega C effective, where C effective is CDS plus CG by 2. And what is Y0? It is equal to 1 by Z0. So this same equation can be used to calculate insertion loss and isolation. Only thing is, you have to take the respective values in the on state and off state. So that's all for this session. More in the next session. Thank you. Thanks a lot, and I wish you all the best.